Welcome back to our sequence on researching the need within the engineering design cycle. Today we will look critically at the credibility of the information we have gathered during researching the need. That information which is credible we will retain for the preparation of external documents, including proposals, design reviews, and so on. Information that is not credible we may retain for internal use only or discard altogether. And information that is in the middle or somewhat credible we will try to back up with other credible sources. While evaluating and filtering information for credibility can be tedious and not as fun as other parts of the design cycle, it is very necessary to supporting our arguments, our case, our design, and often our products and our jobs. In this session, we will look at those sources of information which are highly credible and can and should be used to support the case for our engineering design. As a reminder, in this stage of the engineering design cycle, we have already identified a problem or been given a problem that needs to be solved through engineering design. At this phase, Research the Need has two purposes. Researching the need justifies pursuing the design, including requests for resources to support all the phases of the design cycle, and subsequent iterations of it in improving and polishing the design. But researching the need also gives us the opportunity to identify potentially similar products that are already out on the market. It can truly be a bad dream come true to jump into the deep end of a design only to find out that a similar product has already been designed, marketed, or even flopped. With this in mind, let's get started on creating a firm and credible foundation on which our design can stand, rather than falling victim to the winds of change, whether in a classroom, research, or corporate environment. There are many places to turn for gathering information about a design and a potential product. Once we have gathered information, though, it is extremely important to filter it so that credible information rises to the top of our formal documents distributed outside the team, while the less credible information may be discarded or retained for internal use, and that information in between is paired with credible data or used cautiously. This table provides a starting list of potential sources of information to support researching the need and the potential credibility of each. Most of what we will easily find on Google and other search engines is likely to be of questionable credibility. On the other end of the spectrum, information which is more time-consuming to find, such as that from the peer-reviewed literature, is likely to be the most solid and credible, and well worth the effort to find and use to support our design case. In this session, we will look at the most solid and credible sources, peer-reviewed journals and conferences, established trade magazines, reputable market research, and information from reputable government and unbiased non-government organizations. Beginning with what's most often considered the most credible source of scientific and engineering information, articles from peer-reviewed journals can be located in any number of databases, including but not limited to IEEE Explorer, Google Scholar, and the Web of Science. Let's take a look at a sample search in IEEE Explorer. Here we can enter a search term, and in our example we'll look at RFID and biomedical applications. And we'll find quite a few results, 278 results. And our first result here, an integrated full-wave CMOS rectifier, is found in IEEE Transactions on Circuits and Systems 1. Now, if we know nothing about this journal, we may choose to go to a website like eigenfactor.org and take a look at how credible IEEE Circuits and Systems 1 is. And in the search box, we'll just go ahead and enter IEEE Circuits and Systems 1. And there it is, the regular papers. We'll find the journal. And here we see two scores available for journals in the Eigenfactor database. The first, the Eigenfactor score, represents the impact of the journal rated according to its citations in other journals. Higher ranked journals which cite articles from a particular journal are weighted more heavily than lower ranked journals. Eigenfactor scores are scaled for all journals listed in Thomson's Journal Citation Reports so that they sum to 100. For example, IEEE Transactions on Circuits and Systems has 0.02% of the total influence of all indexed publications, which puts it in the 94th percentile among journals. The second of the Eigenfactor metrics, the article influence score, represents the average influence of its articles over the first 5 years after publication. It is calculated from the Eigenfactor score with the total number of articles in a journal in the denominator and is intended to compensate for the size of a journal in determining its influence. In our example, IEEE Transactions on Circuits and Systems 1 has an article influence score of 1.3, which puts it in the 87th percentile of article influence. Both these Eigenfactor and article influence scores for this journal are quite good, so we can see that this journal is a highly credible source and then can be used to support our design position. In contrast to peer-reviewed journals, which are objectively evaluated in the Eigenfactor and related measuring systems, peer-reviewed conferences can be trickier to evaluate for credibility. One step below peer-reviewed journals, peer-reviewed conferences are considered often credible. A few strategies can be used to evaluate the credibility of a conference. Let's take a look at an example, the International Symposium on Circuits and Systems. The first thing we notice about this conference is that it is sponsored by a major and reputable trade organization, the Institute of Electrical and Electronics Engineers, an established society founded in 1963 and today has over 400,000 members. The next thing we can look at is whether the conference is truly international. If we take a look at those in charge of organizing the conference on committees, and we scroll through this list, we find that, as expected, many of the local arrangements are led by local people, in this case in Portugal. But we also notice that leaders of these committees come from all over the world, North and South America, Asia, and Europe, suggesting that the conference is truly international. A truly international conference is likely to be more credible and have more stringent acceptance guidelines than a regional or more local conference. But beware, the word international in the title does not necessarily mean that the conference truly represents a broad range of participants around the world. Finally, we can briefly search to see if the acceptance rate for this conference is competitive. If we Google ISCIS acceptance rate, you'll find that the acceptance rates in past conferences are around 50%, which further improves the credibility of information found in papers for this conference. A note of caution, however. Acceptance rate alone is not the whole story behind the credibility and reputation of a conference, and should be used only in conjunction with other information to establish credibility of the conference. Another option for establishing the credibility of information from conference articles is to search for a follow-up journal article by the same authors. Authors in science and engineering research often write journal articles on the same topics as an earlier conference article to expand and formalize the data presented at a conference. Moving on now from technical conferences, trade magazines can also be a credible source of information to support engineering design. Like conferences and journals, however, not all trade magazines have similar reputation and credibility. In evaluating a trade magazine, it's important to look at the reputation of the sponsoring organization. For example, the trade magazine IEEE Spectrum is sponsored by IEEE, which is an international organization of electrical and electronics engineers, established now for over 5 decades and with over 400,000 members, making it highly credible and suggesting that its trade magazine is also likely to provide credible information. The same is true of the smaller Society of Petroleum Engineers. The Journal of Petroleum Technology, a magazine of the Society of Petroleum Engineers, is the flagship magazine of that organization and is likely to contain credible information. While not an all-encompassing list, this list of professional trade organizations in the United States is a good start at understanding which sponsors and which trade magazines are better sources of credible information than others. Trade magazines sponsored by organizations outside of the list should at least be checked out to ensure that there is no inherent bias, such as sponsorship by a company that has an agenda or the appearance of an agenda. In addition to peer-reviewed conferences and journals, as well as trade magazines, market research can also provide valuable and often credible information to support answering the 3 key questions we have regarding competing products, markets, and societal need for an engineering design. Some free and reputable sources of market data and specifics are available from the United States government, including that provided by the Small Business Administration, the U.S. Census Bureau. Statistics and economic indicators provided by these organizations are often generalized, but can provide an important compass to support the future profitability and potential market expansion of engineering designs and products in certain product sectors. When federal government market research, although credible and reliable, is insufficient to fully support researching the need, private market research organizations can be used to supplement or replace government data. In general, private market research firms provide more specific information regarding market volume, projected market share, and related metrics for technology products. However, private firms often charge a great deal of money for detailed reports. Fortunately, they provide valuable and credible teaser summaries free of charge online with highly credible and reliable market data to support many high-technology product areas. Finally, some market research organizations, such as Pew Research, are not-for-profit or non-profit and provide credible, unbiased information to support identifying numbers and types of customers for a particular design or product. Government organizations can also provide information that is credible to support researching the need for a chosen engineering design. The more stable, the more established, and the more recognized the government, the more credible the information is likely to be. At the U.S. level, this means credible information can be mostly guaranteed from such agencies as the Environmental Protection Agency, the Food and Drug Administration, Department of Agriculture, Center Disease for Control, National Institutes of Health, and many others. When moving to smaller entities in the United States, credibility is often presumed to be weaker than at the federal government level. As a result, information from city, county, or state agencies often must be backed up by information from more credible sources. Likewise, information from less stable or less well-recognized governments should also be taken with a grain of salt and backed up with more credible sources. Closely related to government organizations, non-government organizations, or NGOs, can also be a credible source of information to support researching the need for an engineering design. The same rule applies to NGOs as for government organizations in evaluating credibility. The more established the agency, the better. For example, the Peace Corps and American Cancer Society that can be considered reputable and credible sources from which to draw information regarding needs in developing countries and various forms of cancer, respectively. The World Health Organization, while not technically an NGO due to its affiliation with the United Nations, is also an excellent, highly reputable, and credible source of information. Many NGOs, however, must be evaluated with caution, and information from organizations with evident bias, such as the Greenpeace mission shown here, should be recognized at best as somewhat credible and backed up with another, more credible source. Often we can find this bias by looking at the mission statement of the organization, shown here between PATH, which has a fairly objective mission, and Greenpeace, which has a more emotive and likely biased mission statement. In this session, we have looked at finding the credible sources of information among all the information and data we have gathered to support our design. As a result of our filtering process, we may have to move some information to the somewhat credible category, or even the not credible at all category. Regardless, from this first phase of filtering, we will have identified the information that can be most confident in presenting and using to support our own design and moving forward in the engineering design cycle. This concludes our introduction to credibility in the research the need phase of the engineering design cycle. Thank you for joining us. We certainly hope that this session has been helpful to filtering information and establishing a solid, credible foundation for engineering design, and that you'll join us again as we take a detailed look at other phases of the design cycle.